So in today's video, we're going to be working on a HR dataset, and we're going to be carrying out analysis on employee data. So I'm going to be using Microsoft SQL Server Management Studio, and I already have it open. So first thing we're going to do is start with our database. So I'm just going to come over here and I'm going to right click and I'm going to click on new database, and I'm going to name this database employee data 2 because I already have employee data, so I'm just naming it 2. You can name it whatever you want, and I'm going to click on OK. So I'm going to come over here. I'm going to create a new query. Once again, give this a moment and I'm just going to open it. So over here, you can go ahead and just select what particular database you want to reference. So for me, it's already set to employee data 2. So if it's not set to that, go ahead and then select this drop down and then select the proper database you want to use. Next, we're going to import our data. So I'm going to come over here to database, and I'm going to right click and we'll go to tasks, and then we're going to select import flat file, and this import wizard will come up. I'm going to go to specify input file next, and I'm going to browse, and I'll just go to where my data is and I'm going to select it. The link to this particular data set will be in the description box below. So this table name, I'm going to leave it as it is, and I'm going to move on to next, and we're going to see a preview of our data. And this is what it looks like. We have our employee ID, first name, last name, gender, age, so on and so forth. But yeah, this is what our data looks like. Now let's go to modify columns, and we are going to, in this one it says allow null. We'll leave it like that, and for every other thing we're going to leave it as it is. I don't think, no, there's nothing we need to change. We're just going to leave everything okay, with one exception. I'm going to change this to end voucher 50. That's promotion last year's. Instead of bits, we're going to change it to end voucher 50. But yeah, that's it for this section of our video. So next, and I'm just going to click on finish, and we have inserted our data, and I can go ahead and close this. So let's take a look at our data. I'm just going to select all from employee data. So I'm referencing the table. And I'm just going to use F5 to run this query. And so this is what our data set looks like now that we've imported it. So we can go on to look at other queries. So let's take things one step at a time. Let's say we want to look at want to see the number of employees. So I'm going to, because now we have these data sets, I think we have 1000 entries. Well, let's say you wanted to just count how many employees you have based on the employee ID. So I'm just going to select, and I'm going to count, and I'm going to count all as, let's see, number of employees. From employee data. So once again, we're going to we're referencing our table, and it's not it's supposed to come up. Don't worry, I'm going to fix that in a moment. Employee data. So I want to count all the data entries in employee data. So once again, it's 1000. By just scrolling down our entire data set, we could see that it was 1000. But just in case you have a large data set, or you're working with, let me say, products that have unique IDs but come up multiple times in your data set, you might want to count each one individually, and the number of entries may not reflect the number of items or number of people or number of whatever things you're counting. So this is a good idea to do. So this squiggly line, this red line you're seeing here, although it's showing that it's quote unquote an error, it's actually still running fine. So what's going on? We just need to refresh it. So hold Control Shift R, and in a moment you see that this red line will disappear because what I've essentially done is refreshed. And this is what, so if you're having that same issue, you can just go ahead and change that, and you can see now when what tends to come when you're trying to reference the table is supposed to come up. It wasn't coming up, but now it's coming up this time. So just use Control Shift R to refresh, and those red lines will disappear. Let me just let me add the comments so that we don't get too confused. So this is number of employees. Okay, so now we can move on to the next one. Next, let's look at the let's look at department and job titles. Department and job titles. So we're going to do a distinct count, so of the items in distinct. So we're going to do select distinct, and we're going to reference, let's start with departments, the department column in our data set from employee data. Oops. So we're going to reference the table. So let's look at this F5 to run this. So these are, we have 8 departments, which is marketing, sales, R&D, IT, customer support, human resources, and finance operations. I'm going to copy this, and I'm going to do a distinct count for job titles. So it's going to be job title, and I'm just going to run this query, and these are the job titles. So we have R&D manager. Oh, there's quite a bit. There's 24, so I won't just go and read all of them at once. So we have 8 departments and 24 job titles. Next, let's see how many employees are in each department. So I'm going to select the department column, and I'm going to do a count. So let me just copy this entire thing from here. I'm just going to copy this, and I'm going to paste it. So I want to count all as number of employees from the employee data table. Next, we're going to group by. Let's group by departments, and I'm going to, let me use lowercase for this instead of uppercase. Let me group by departments. And these are the number of employees according to departments. I think, okay, IT has the highest number of employees, followed by marketing. You know what, let's do order by as well, so that we can see the, not just the number of employees, but from highest to lowest, so we can see which department has the most number of employees. and which has the list like that. And I'm just going to select the entire thing, run it. Oh, it was not IT, it was finance. Okay, fine. So if this was a much larger data set and we're dealing with more values, it would have even been harder. I thought it was IT and somehow I missed that it was finance. So finance has the highest number of employees, followed by IT, with customer support having the lowest number of employees. Next, let's see. Let's look at the average salary. Let's look at the average salary. And I'm just going to come down here. Let me scroll down a bit. And I'll just type in select. And we are going to do the average of salary as average salary. And this is going to be from the employee data table. And I'm just going to run this. Okay, this is the average salary in our data set. Let me round this so that it won't have those. Let's round it down to 2 decimal places, and I'm going to just run this entire query. Okay, this is our average. The average salary is 93,666.66, and yeah, that's it for average salary. Let's do something else. So let me just copy. I'm just going to bring this to another line. Let me bring this because I want to do. Let me do other things as well. Instead of going to another query, we can just run it all together. So I'm just going to copy that and paste it. Let's say performance rating here. So oops. So let's look at the performance rating while also looking at salary, instead of doing all of them one by one. So we can look at everything in one table. Average performance. And I'm just going to run this. So the average performance rating is 3. You know, we can just keep adding things to this query. So let's just go ahead and do that. So once again, I'm just going to paste. Let's look at the average attendance. Let me see, attendance. What's the name of the table? Okay, so now attendance, this would be average attendance, and let's also do the average bonus. As this would be average bonus. And let's run this. So average salary is $93,666 and average performance is 3. The average attendance is 87.37 and the average bonus is 11,569. I don't know. Let's add the number of employees. Let's just make it a comprehensive summary of our entire data sets, where with this single query we can have like a cursory summary of our entire data set. So we can have the number of employees, and what else can we do? Let's look at the average promotion. Let's see the percentage for promotion. So I'm going to add one more query. So we are going to, no, that was not what I wanted to go for. I'm going to just copy this, and I'm going to paste it here. So this is going to be sum and we're going to use case when promotion in last 3 years equals 1, then 1, else 0, and we can end. This is going to, we're also going to, so we want to look at percentage, so we're going to multiply by 100, and I'm just going to multiply by 100 divided by the number of employees. And we're going to see this as promotion rate. Oops. And I'm just going to run this. This promotion rate is kind of wonky. So we have 1,000 employees. Average salary is 93,666. The average performance is 3. Average attendance, I just noticed that there's a typo here. Sorry about that. And let me just run this one more time. Average attendance is 83.37%. The average bonus is 11,569. And finally, the average promotion rate is 53.2%. So based on whatever it is you're trying to look at, let's change this to just summary. So instead of doing each one of these separately, we just did all of them all together. So I'm just going to write summary. So this is basically a summary of the performance of the entire employees, their average salary, attendance, bonus, and the promotion rate. Alright, so since we've done the summary, let's do other things. Let's see, because we're working on average salary in the beginning, then we'll move to like a summary. So let's look at average salary by departments. Okay, so let's select, we're going to select the department column, and we are going to, I'm just going to copy this, so of typing it out again. We're going to get the average of the salary, and it's going to be from the employee data table, and we're going to group by group departments let's go ahead and run this query. So okay, this is the average salary. Let's add order by, let's order by average salary, and we're going to do it descending, so we can see from the highest paid department to the lowest paid department. So based on our analysis, on average human resources, the human resources department has the highest salary, followed by customer support, finance, sales, operations, IT, R&D, and then finally marketing is the lowest paid department with it's $9,640. That's about like I said, that's is it $8,000 difference between the highest and lowest paid departments. I don't know if I got that right. Okay. Anyway, but this is what we have for the average salary by department. Now that we've looked at the average salary by department, let's look at the average salary by education level. So I'm just going to copy this entire thing, including the comments, and I'm just going to paste this here. So we are going to change this to education level, and instead of selecting the department column, this time I'm going to reference the education level column. We're going to leave every other thing the same, and we're going to just let's leave it like this and see. So I'm just going to run this. Oops, what have I missed? Oh, group by education level, and I'm just going to run this. So bachelor's degree, interestingly, has the highest average salary, then followed by PhD, high school, then masters. Okay, this is not a real data set because I would expect PhD, then masters, bachelor's, then high school. But anyway, based on this, this is not a real data set based on a real company, so I'm not going to take it really seriously. But based on this particular data set, this is the average salary by education level. For our next query, let's look at the highest paid employees. So I'm just going to highest paid employees. So I'm going to select we're going to do top, so let's do top 10 because we have, I believe, 1,000 employees. So let's just do top 10. First name, last name, then we'll look at their department's job title, and of course their salary. And we're going to reference our table. Oops, let me go to another line. I'm going to reference the employee data table, and we're going to order by salary since we want to see the highest paid. So order by salary in descending order. Now I'm just going to run this query. So is it Jacqueline? I don't know if I'm saying that right. Myers in IT has the highest salary of $149,884. Then Andrew Lee from Human Resources is a recruiter, and so on and so forth. If you want to look at the top, let me say 20. Let's change this to 20 so that we can see. And now the limit is increased to flow from the highest paid to the 20th. It's just difference of $2,000 if I'm not mistaken. So you can go on so on and so forth to see the highest. If you want to see the highest to the lowest, you can just order the employees and just change the order and remove the top. Instead, you can look at all the employees, but that's going to be quite redundant because we have a lot of employees. But yeah, that's it for this particular query. Next, let's look at the average performance by department. So we're just going to make this average performance by department. So let's select the department column, and we are going to get the rounded average instead of just going with the average. So round, and we're going to get the average of the performance rating column, and this is of course going to be rounded down to 2 places as average performance. And it's going to be from employee data. We're going to group by department, and let's order it by the average performance. Then we're going to go in descending order, and I'm just going to run this. So marketing on average has the highest performance with just 3. Then we have sales, R&D, with operations and IT having the lowest average performance. And let's check if there's a correlation between years of experience and performance rating. So I'm just going to make this correlation between experience and performance. So what I'm going to do is just copy this entire thing instead of typing this again, and I'm going to paste it. Next, we're going to use, let's compare this since we want to check the experience. So this will be experience years, and we're going to leave this as it is. Then let's change this group by to experience years, and this is also going to be experience in years. I don't think there's, let's see how our query looks like. Let's run this. Okay, so we have this experience 0 experience, we have 2. I don't think there's any really, because we have someone in 2 and we also have someone with 20 years of experience still having average performance, and we have lower years of experience here and even here. So I don't really think, but if we're doing a better analysis, maybe we could see if there was better way we could compare. But yeah, basically that's just a very simple correlation analysis between years of experience and performance. Now let's do something similar to this. once again. So since we are trying to look at, we couldn't really see much details here. Let's look at it at an employee level. Let's look at specific employees. If we can see whether there are certain employees that meet the criteria of high years of experience, long years of experience with also high performance. So let's see employees with long experience and high performance. So let's start with, let's select the first name, last name, the department, job title, we're going to also show the experience, yes, and their performance rating. And this is going to be from the employee data table. And since we want to check those that their experience in years, so you can choose where experience in years. So we have experience in years up to 20 years. So let's just put it around the half mark. So we'll go, well, let's use 10 as the years of experience. So I'll just put where experience years is greater than 10 and performance rating is greater than or equal to 4. And we're going to order by let's order by performance rating, and we'll do it in descending order. Let's run this query. So we have of our 1000 employees, we actually have 207 employees, which is about 20% of the employees in our data set. So about a fifth of the entire employees actually do have high experience, where you can see their experience in years is all those that have 10 years of experience, more than 10 years of experience, and their performance rating is between 4, is either equal to or greater than 4. Yeah, that's it for this particular query. For our next query, let's look at the gender distribution of our data set, and we're going to look at it as a percentage. So I'm just going to go over to a new line, and this is going to be, I want it to be lowercase, gender distribution. Okay, so we're going to select the gender column, and we are going to do a count all, and it's going to be as counts, and this time we're going to do So let's start with round. So I won't have too many decimal places. We will, but it will be rounded down. I'm going to create another bracket, and we're going to do a count all multiplied by 100 divided by number of employees I'm going to write it out like I'm going to write it out like this. I'm going to reference the employee data set, so the employee table data set. So we're going to reference the employee data, and I'm going to close this bracket, and we're going to round it down to 2 decimal places. Then it's going to be as percentage, and all of this we're going to now reference from the employee data, and we're going to group by gender. There's no need to do order by, since we're just working with 2 values. So I'm just going to select this, and I'm going to run this. So the number of employees for male is 511, female is 849. That's 51% and 48.9%. That's pretty straightforward, because we are dealing with a data set that is 1000. So 1000, I believe, is 1100 is essentially the same thing with just one less zero. So it's expected that the count and the percentage is essentially the same thing. But yeah, that is the number of employees by gender and also the percentage of their distribution. Now let's look at the gender distribution according to department. So I'm going to select this entire thing, copy it, and I'm going to paste here. Let's start with this line. I'm just going to completely remove that. So since we want to look at it from a department to department basis, we're going to reference the department column, and we are going to group by department and gender, and we're going to order by department. Okay, so let's run this, and this is what we have. So in customer support, there are more female employees than male. In finance, same thing. No, in finance there are more male employees than female employees, and human resources more female than male, IT more male than female. So that's what we have for the gender, and you can look at the other departments. So research and development, more male employees than female employees. There are 72 employees in R&D, while there are 53 in this. In sales is almost equal, 61 to 62. But yeah, that's the gender distribution by department. Oh, let's also add it here by department. Next, let's look at the average age by department. So I'm just going to move on to the next line, and we're going to look at the average age by department. So let's select the department column, and we're going to get the average age as average age, and this is going to be from the employee data table and we're going to group by let's group by department, and I'm going to run this query. So the average age depending on departments is, so we have marketing as 41, sales 39. What if we wanted to see, let's order it from the highest to lowest so we can have a more detailed understanding of what we're seeing. Let's order by average age, and let's make it descending so that we can make some sense of what it is we are looking at. So I'm just going to go ahead and run this. So research and development, IT, marketing and operations has the average age of about 41. Finance and customer support has average age of 40, and finally we have human resources and sales having the average age of about 39. And that's it for the breakdown of the average age by department. Next up, let's look at the attendance by department. So let's move on to another line and we'll look at the average attendance by department. So let's select the department column and we are going to get the average attendance rate. So we're going to reference the attendance rate column. So and this, we're going to get our results as average attendance, and this is going to be, of course, from the employee data table. And since we're doing it by department, we're going to group by department, and let's order by the average attendance in descending order so we can see at a glance which department is most punctual and which is most tardy. And we're going to run that. Ooh, this looks let's do round so that our results will be much cleaner. So I'm just going to round this average to 2 decimal places. Run this again. So HR has the highest attendance rates by 88.31%, and the most tardy is but still it's still good because all attendance is within 80%. I think 80% is a good number. 88 between 88 and 85%. I don't think that's really much of anything, but based on our data sets, human resources has the highest attendance rates, while research and development has the lowest at 85.8%. Yeah, that's the breakdown of attendance by department. Let's look at another metric. I believe we've looked at employees with long experience and high performance. Let's look at another one. Let's look at some employees with, let's say, high attendance and low performance. You can also do the opposite where you look at low attendance but high performance, something like that. But let's do employees with high attendance but low performance. So let's use their first name last name, let's use the departments, the attendance rates, and we're also going to use the performance rating. And of course, we're all going to be referencing this from the employee data table. So let's set our conditions. So it's going to be where attendance rates is greater than 95%, and performance rating is less than or equal to 2, and we're going to just order by the attendance rates in descending order. Okay, let's run this query. So the attendance rates, that's interesting. The attendance rates of this particular employer is actually very high. So you can even see we even have 99.94%. We can round this up if we want to, but let's just leave it like this. But their performance rating tends to be is also low. So yeah, it's possible to have employees with really high attendance rates but low performance rates. If you want to try something different, maybe check for let's do something. Let's try the other side. Let's see where performance rating is high but attendance rate is low. So what I'm going to do is, we are saying attendance rate is greater than 95%. Let's use where their attendance rate is less than, let's see, I don't know, I'm not sure of the range for this particular data set. Let's say less than 80%, and their performance rate is less than or equal to, let's use 4 because that's what we used earlier, I believe. So I'm just going to run this. So we have some performance rating. No, let's see, greater than or equal to 4, and we do have some employees whose attendance rate is, although it's less than 80%. Let's try something even lower. Let's see, I don't think does our data set have anyone that has less than 70? It doesn't. Let's try 75. Doesn't. So I believe we'll go just leave it at 80. Oops. So we do have some, in general, I think performance rate tends to be around 80%. So that's attendance rate for this particular data set is around 80%. So we do have, anyway, based on this particular, whether 80% is good or bad, it's neither here nor there. It's just based on this particular data set. Well, yeah, that's it. Let me just return this particular query back to its original form where we were looking for high attendance, low performance. So I'm going to change it back to where attendance rate is greater than 95, and this is going to be less than or equal to 2, and I'm going to run this query again. Yeah, that's it for employees with high attendance but low performance. For our next query, let's look at the average overtime by job title. So this is going to be average overtime by job title. So we're going to select the job title column, and we're going to get the average overtime hours. Sorry, slight typo here. As average overtime. And this is going to be from the employee data. We're going to group by job title. And we're going to order by average overtime in descending order. And let's run this. So logistics officers tend to have the highest overtime, or there's quite a bit. So we'll just look at, let me say, the first 5. Support agents, next HR assistants, support manager, operations manager. So those are the top 5. And for those who get the list, we have customer service rep, sales manager, product designer, finance manager, and financial analyst. So that is the breakdown of overtime by job title. Next, let's look at the average bonus by department. So let's look at average bonus by department. Okay, so let's select departments, and we're going to get the, let's round it just in case, but since we're working with salary, I think we need a round function. I'm going to round it, and we're going to round the bonus to 2 decimal places, and this is going to be the average bonus, and this is going to be from the employees data. I'm going to group by departments and order by average bonus in descending order. Now let's run this query. So customer support has the highest bonus, followed by sales, then finances, human resources, R&D, operations, marketing, and then finally IT. For the next query, let's look at the employees who have been promoted in the last 3 years. So I'm just going to employees promoted in the last 3 years. So we're going to select and then count all as promoted employees, and we're going to count all multiplied by 100 divided by number of employees. From employee data, like this, and we're going to present the result as, let's say, promoted percentage, and this is going to be from employee data, and this is where Now we're going to reference the promoted last 3 years column is equal to 1, and I'm going to run this. So we have 532 employees promoted in the last 3 years. Once again, our data set is 1000, so that's why the percentage is very close to the number, because it's essentially just one decimal point from 1000. But yeah, this is the number of employees that have been promoted in the last 3 years. Next, let's compare the performance of those promoted in the last 3 years, those promoted and those not promoted, employees not promoted. So I'm going to say performance of promoted and non-promoted employees. So I'm going to select the promotion last 3 years column, and we're going to get the average of the performance. So we're going to get the average of their performance rating, and we're going to get this result as average performance and we're going to compare that with their salary. So I'm going to check the average of the salary column as average salary. Then of course we're going to reference the employee. That will be from the employee data, and we're going to group by promotion in last 3 years, like this. Now let's run this query. So those that have been promoted in the last 3 years and those that have not. So these are the employees that have been promoted in the last 3 years. These are those that have not. So average performance the same. Salary, interestingly, those that have been promoted have on average have lower salary than those that have not been promoted. And yeah, that's it for this particular query. For the next query, let's use the location this time. So let's look at the number of employees by location. So I'm going to select work location, and we're going to count the number of employees in by work location. So counts as number of employees, let's see. And we're going to reference our table, which is the employee data. We're going to group by location, and we're going to order by number of employees. In descending order. Okay, let's run this query. And so Denver has the highest number of locations, followed by San Francisco, then Chicago, Seattle, Los Angeles, New York, Boston, and then Austin has the lowest number of employees with 110. For the next query, now that we've looked at the number of employees by location, let's now see the average salary and performance by location. So I'm just going to select this entire thing and I'm going to paste it here, and this is going to be average salary and performance by location. So okay, we already have location here, so now I want to look at the average. This is going to be a longer query, so I'm just going to delete this and we'll move on to the next line. So we're going to take the average of salary as average salary and we're also going to take the average performance. We're going to check the average performance of this location. So we're going to use performance rating. And this will be as average performance. And this is of course going to be from employee data. We're going to leave work location and let's order by average salary. And I'm going to run this query. Let me round this. I don't like the format, so I'm just going to round the salary average to 2 decimal places. So now Chicago has the higher average salary and it also has rating of 2. So just Los Angeles and San Francisco have a rating of 2, the rest have a rating of 3. Chicago has the highest average salary, with Austin having the lowest average. Now let's look at the breakdown of the employment status of the employees in this data set. So I'm just going to look at employment status, and we are going to select employment status, and we are going to count the number as, let's just use number, let's say number of employees, and this will be from the employment data, and we're going to group by employment status. Okay, so based on our data sets, the distribution is those on leave is 339, Those that have been terminated is 340, and those active is 321. Let's look at the, let's say, the average tenure. I think that's something we haven't touched on yet. So let's look at the average tenure by employment status. Okay, so let's select the employment status column, and we're going to look at, let's start with, we're going to do the average, then we're going to use the date function because we want to subtract here. So, and then we're going to use the year column, and we're going to specify that we're using the higher dates column, and we'll get dates, and you can just close all brackets like this. It's supposed to be like this, and we're going to specify that it's going to be as average tenure. Let's group by employment status. And we're going to order by average tenure. I just noticed an error in my query. Sorry, because I didn't specify the column. I was wondering where this error is coming from, so I missed the obvious. I'm not referencing my table, and I'm going to run this. So the average tenure is the same across all employment status for on leave, terminated, and active. And yeah, that's it for this query. Let's run one more query where we'll look at let's say team sizes. So we want to look at how many employees are under each manager. So I'm going to look at, we want to look at the number of employees per manager, and we're going to select the manager ID, and now we're going to count the employees within that column as team size. So let's let me write the count first. As we're going to say it's, yeah, team size. This is of course going to be from the employee data, where, because remember in our data sets, when we're importing our data sets, some of our data in manager ID is null because not all employees are managers. So I'm going to write where manager ID, so that it won't count the null values. Where manager ID is not null, and we're going to group by manager ID, and we're going to order by team size. in descending order like this. So let's run this query. So this is the manager ID. If you want, you can also see, if you wanted to, you can add the first and last name of the manager so you can see their names, but the team size under each manager is just 2 or 1. And yeah, that's it for this particular data set. You can play around with the queries and change things around if you want, but that's it for this tutorial. If you enjoyed the video, please like, share and subscribe, and I'll see you in the next one.